Welcome to today's lesson. We are still on the remainder theorem. In our previous lesson, we saw some examples. We looked at how we can um, find the remainder of a given polynomial function when it's divided by another polynomial function. But today, we have a very nice question brought by one of our students. We are going to look at how we can solve such an example. Since we previously solved some of them, let's also look at how we can solve this example. As I said, you need to solve more examples on that, and the more you do, the more you get the concept. All right, so without wasting much time, let's quickly look at the question one of our students brought today for us to see how best we can find the unknown values. So this is the question the student brought. So in this question, we are saying that when the polynomial function, that is h of x, is given as 2x cubed plus px squared plus qx plus 1 is divided by x plus 1 or x minus 4. The remainder is 5. So here we are to determine the values of p and q. That is what is given in this question. So we are going to look at it quickly. Okay, so looking at this question, if you compare to the previous one we solved, you realize that in that example, we're to divide a polynomial function by only one linear function. But in this case, we are to divide it by what? Two different linear functions. And when we divide by these two different linear functions, we are going to have the same what? Remember, if that is the case, then what values of the p and q will be when we divide what? The polynomial function by these two linear functions. And that's what we are going to look at. So as I said, for this one, before you can do this, whenever it's given to you, you need to find what? The zeros of the divisor. So in this case, we have these two divisors, and these are the x plus 1 or x minus what? 4. These are the two divisors that we are going to divide the function by, and then we get what? The remainder. So let's look at how we can go through the solution. So my dear students, I will want you to pay attention. You have to follow step by step so that you get the concept at the end of the solution. All right, great. So this is the function given, and then we also have the remainder as what? 5. Okay, so it means that when we divide this polynomial function by these two divisors, we are going to get what? A remainder of 5. So let's test and see if it is going to work like that. All right, great. So as I said, always find the zeros of whatever divisor given to you, and once you find the zeros, what do? You substitute the value. If you substitute the value, whatever is given in the question, or whatever answer you get becomes what? Your remainder. In this case, we are already given the remainder as 5. So we are no more going to look for the remainder. We are not looking for the remainder. What are we looking for? We are looking for what? The p and q. Okay, all right, good. So for x plus 1 is equal to 0, and we are going to get what? X is equal to -1. And also we have what? Another divisor, which is x minus 4. So, or we can have x minus 4 is equal to what? 0. All right, great. And then we can have x as what? 4. So these are the two values of what? X. So these are our zeros of this what? Polynomial function. Okay, great. So we are going to substitute these two values so that we see which values will be what? P and Q. That is what we are going to do right now. All right, great. So let's quickly do that. Great. So let's see how, and we know that we are given the remainder as what 5. So we are going to substitute -1, and when we substitute -1, the remainder is going to be what 5. Okay, if that's the case, then let's see how this is going to work. Okay, great. So when you substitute the -1, this is what you are going to get. You are going to get what 2 multiply -1 cube plus p multiply -1 squared plus q multiply -1 plus 1, which gives the remainder 5. Okay, great. So let's continue and see what we get. Now when you do it this way, you are going to get what, if you take the cube of what -1, you are still going to get -1, and when you multiply by 2, you get what -2. And when you take square of what -1, you are going to get +1. So when you multiply by the p, then you are get what p minus what q plus 1, and that gives what 5. So in this case, what do? We have p and q. Then we can group like terms. We can put the p and q as letters standing at one side and send what the constant or the numbers to the other side, and that gives us what p minus q, which is equal to 5 plus 2 minus 1, and that gives us p minus q is equal to 6. Have you gotten that? Great. So you have this. If that's the case, then we can call this equation 1. Okay, so this becomes our first equation because we are still left with what the 4. We use the -1, and this is what we are getting. Then we also have to use the 4. Okay, so if we use the 4, then it means that if you put 4 into the polynomial function, the remainder is going to be 5 as it was given in the question, and that is what we are looking at. Okay, great. So let's see, if we substitute the values, what are we getting? So as you can see, you put what 4 in place of what x. Wherever you see x, you put 4 there, and if you simplify, you are going to get 2 multiplying what 64, because if you do that, 4 exponent 3 or 4 cube gives us what 64. And then we also have 4 squared, which gives 16. Then we have 4 there. So let's multiply, and we are getting what 128 plus 16p plus 4q plus 1 is equal to 5. So we can group like terms, and this is what we have. We therefore what have 16p plus 4q is equal to -124. That is what we have. Now if we have this one, we can still reduce it. We have 16, we have 4, we have 4, so we can still reduce it. We can divide through by what 4. Okay, yes, so we can divide through by 4, and if we divide through by 4, what are we going to get? We are going to get 4p plus q minus -31. Okay, yes. So once we have this, then we can also call this equation what 2. Okay, yes. So now we have 2 equations, and looking at this, if you remember, this is one of the concept that we've done. This is what simultaneous equation. So equation involving what 2 variables. Okay, equations involving 2 variables, or linear equations involving 2 variables. All right, good. So since we have 2 equations like this, then we are going to solve it what simultaneously. Okay, so let's look at how we can solve these 2 equations. All right, great. So for simultaneous equations, how do we solve simultaneous equation? If you recall, we can see that we can solve this either by substitution method. We can also use the elimination method or graphical method. This three methods or approaches can be used to solve simultaneous equation. But in our case, we are going to employ the use of a substitution method. Okay, yes, some prefer using elimination method. All right, but I want us to focus on the use of substitution method. Okay, there is no special reason for using that because you can choose any of the methods, either substitution, elimination, or graphical. I prefer using the substitution. Okay, so if someone uses elimination or someone uses graphical, at the end of the day, we are all going to get what the same answer. So nobody is wrong in any way. All right, great. If that's the case, then if I'm using the elimination method, then I'm going to consider equation 1 because looking at this, the unknown variables, they have what smaller coefficients. So since they have smaller coefficients, then I'm going to do the substitution. Okay, great. So from equation 1, I can make P the subject. Okay, I can make P the subject. If I'm making P the subject, then I can transpose keep P at the left side and transpose negative Q to the right side, making it what positive. So that is what I'm going to have. So I have what P is equal to 6 plus Q. Okay, and I still have another equation. Therefore, I will call this equation what 3. All right, good. So this is my third equation. Once I have this equation, then I can substitute P is equal to 6 plus Q into equation 2. Okay, so I'm going to put equation 3 into equation 2. That means wherever I see P in equation 2, I'm going to put what? Equation 3 there. All right, so I'm going to put what 6 plus Q there. All right, so that is the process of what substitution method. Okay, great. So if that's the case, then I can write 4 multiplying what the expression 6 plus Q, then plus what Q again, which is equal to 31. If that's the case, then this is what basic. You remember we've done some of these things. These things are what algebraic expressions. So we can expansion of brackets. So we can just expand the bracket by multiplying what 4 by each term. So 4 multiplying 6 gives us what 24, and then multiplying Q gives us what 4Q plus my Q, which is equal to 31. Negative 31, sorry. All right, great. So if we have this, then we can also group like terms. Okay, if you are grouping items, then we have 4Q plus Q is equal to negative 31 minus 24. That is what we have now. Okay, so if that's the case, then we can add 4Q to Q, and that gives what 5Q, which is equal to negative 55. Once you have this, what do? We are finding Q, so we can divide both sides by what 5. Okay, so if we divide both sides by 5, then we are going to have Q to be what negative 11. Okay, yes, so this is our answer for Q. Once we are able to find Q, then it will be easy for us to find what P. And how do we find P? It's just a matter of substituting Q is equal to negative 4 into any of the 3 equations we have. In this case, I'm going to put Q into equation 3, that because that will be easy. Okay, yes, that will be easy. I'm going to put this into equation 3 and solve. And we all know that this is what equation 3, that is P is equal to 6 plus Q. All right, good. So that is what I'm going to do now to be able to find the value of P. So we have it like this, and then we are also supposed to take this. Okay, good. So if that's the case, then all that I will do is I will just put negative 11 in place of Q, and then I'm going to have P, which is equal to 6 minus 11, and then my final answer becomes P is equal to negative 5. Okay, yeah, so this is what we have. We are able to find the value of Q. We are also able to find the value of P. If that's the case, then we can conclude that therefore the values of P and Q are negative 5 and negative 11 respectively. Yes. So my dear students, you brought this question in, and this is how uh, we can solve it. Okay, so there are so many ways. Some people also have other ways that they can solve this question. Okay, but as it stands now, this is what basic. Okay, good. So when you have questions like this, that is how you go about it. Okay, good. So that's the case then. Let's end here and continue next time. But in our next lesson, we are also going to look at factor theory. Factor theory. Okay. Yeah. So we are left with factor theorem, and we are also going to look at the application aspect. Okay. Real life situation where um, polynomial is applicable in our daily lives. Okay, we are going to look at the usefulness of polynomial functions in, because most of the time you hear people saying, so all these calculations, all these long equations, what impact does it have? But it's just that people are so naive, and they don't know the importance of these concepts that we have been learning. Every mathematical concept that we are studying, all of them are applicable in our daily life. Just that we have been doing them in our lives, but we don't know that this particular thing that we have been doing, that is what we have been learning. We have been writing them in a mathematical what statement. Okay, so when we get to that area, it is going to be what interested, so that as you go out to our various communities, marketplace, churches, whatever we find ourselves, we can identify this usefulness of, or the usefulness of this concept. All right, good. So if that's the case, then let's end here. I'm your mathematics facilitator, Evans Okay, and this is Mazris TV. Kindly subscribe, like, and share the videos. Okay, all right. So if that's the case, then see you next time. And bye bye.